Next up, we have Mr. Mehbub Khan, Market Manager, Asia Pacific Microelectronics, Viola Water Technologies. He has 25 years of experience in the semiconductor and microelectronics industry, water treatment and management expert. Today's topic is on front-end wafer fabrication and back-end semiconductor plants. Today, we are racing towards achieving water recycling targets imposed by either local management or government bodies. This topic today will cover best practices of water reclaim and reuse, as well as international benchmarks against one of the best in semicon manufacturing worldwide. So without further ado, shall we give a big hands to welcome Mr. Mehbub Khan, Strategic Water and Resource Recovery with Macro Porous Polymer Extraction towards Circular Economy. Welcome.
Once again, very good afternoon to all of you. The topic is very long. I realize it's the longest topic in the today's so-called forum in terms of the size as well as in terms of the name. I will try to do in this next 25 minutes or 30 minutes, try to simplify it for you. It is about circular economy in terms of water and chemical separation. Yeah? So fab uses a lot of water and chemicals, and how do we help them in terms of separating those two so that they go into a circular economy mode. A bit about me, I'm in this microelectronics segment, but serving the water treatment industry, helping our fabs in Singapore for last 25 years, 26 years. A brief outline of the so-called topic here. So the first topic is we are going to discuss what's going to happen to all the fabs in coming so-called years to come by, especially in terms of rate of recycling, because that's a hot topic being discussed amongst fab, amongst PUB being the Public Utility Board, or those who are our overseas visitors, it is our municipal authority for water. And then the second segment, we will little bit deep dive into technology itself. What is it? This microporous polymer extraction. The third one would be a bit of a case study, so let you feel that it's done and how it's done. And the last one would be, of course, conclusion. We wanted to start with a slide for a fab which is doing a lot, and that you see it on the screen. It's TSMC in Taiwan. And that's where they are achieving quite high rate of recycling. Yeah? Later on, you will see why they are picked, because of the KPI that they have set for themselves and what they are achieving as of today. So there is some red dotted line outline for you. So the key point here is it's not the end of pipe recycling that they are focusing. They are going after specific streams, and that helps them to achieve that high rate of recycling. What are the drivers? The drivers here, the first picture, as probably many of the speakers earlier mentioned, the water scarcity. It's a real picture taken from a so-called Taiwan reservoir where it is feeding to the Hsinchu High-Tech Park. So it came close to, as you can see in the picture, to dryness, and it was a real panic mode situation. So there people were paying like $50 per cubic meter of water, whereas in Singapore, even though new water is there, we are paying a fraction of it, like $2 per cubic meter of water. The second driver is sustainability goals, KPIs, etc., that are being set forth not only by the fab themselves or the industry themselves, but also certain government bodies. And we will talk about PUB a bit later. Cost is another factor. So cost keeps going up in terms of water, not only water, but the chemicals. So today's topic is talking about, again, it's not just about water, but it's also how you gain back your chemical. So that's the interesting part and interesting twist to the whole thing. It's not just about water recycling. The last one, of course, regulation. 30. So the technology that we are going to put forward to you, it's in application, but not maybe in so much semiconductor, but it's there for last 30 years. Yeah. The application to semiconductor is relatively new. 50 is in a specific case here. We are going to talk about a case study where it is IPA or isopropyl alcohol. Many of the fabs are using it, plentiful of it. And how are you going to recover it? And last one, yes, what you see is true. You recover 100% of the water from that wastewater stream. Yeah? So that's pretty amazing. We take you back into a bit of how traditionally things are done. So if you go to any water forum these days, you would hear a lot of presenters presenting you. They use something called as filtration, ultrafiltration, and reverse osmosis. Or sometime, if it's a little bit biological, they would use a MPPE, and they would again go for the reverse osmosis. What we are trying to achieve, or we have already gone into a case study here in Taiwan, where what we are achieving is actually new way of recycling. So what you see in the box, MPPE, and what you are going to get out of it is almost 100% of the water, although there are some evaporative losses, and hence the percentage drops to a little bit lower. But what you get is also IPA, isopropyl alcohol, which I'm sure all of you in the fab industry are using. Here a bit we wanted to talk about, we are in Singapore, so let's talk Singapore context, some of the major fabs. Sorry if some of the other backend fabs are not appearing, but it applies to backend fabs too, by the way, because I see a lot of backend people also here. So this is more on the front end side, and this is what they are achieving right now. They are achieving about 25% to 70% in terms of rate of recycling. Okay, the best fab is only at 70%. In terms of what is others or so-called leaders are doing in rate of recycling, TSMC is at a very different level. They are at 86% right now, and they are aiming to go to 90. Sorry, this is a bit busy slide, but try to focus on the color coding, so easy understanding. So the encapsulated black color is pretty much your fab. On the sides, those blue color circles are what you get into the fab in terms of water, and out on the right-hand side is what you send it out, which goes to PUB eventually and could become a new water. In fact, it is becoming a new water. And within those so-called dark reddish color are the ones which are the major consumer, like your tools, obviously, and cooling towers and scrubbers, both local and central scrubbers. There are some lighter shades which are also a consumer, but they are not high consumers. And what you see, the green color lines are the lines where you are doing the water recycling. This is a typical standard fab situation. Of course, fab to fab things can vary, but 90% of the situation you will see this kind of things happening. And what is going on here is the formula that PUB is going to apply next time when you go and ask for more water from them. This is the formula they would apply. In the next slide is appearing. Try to focus yourself on the Singapore side, and that's what it would be. Don't worry if you don't understand too much of the technicality. The concept here of the formula is what you are recycling, meaning all those green lines in your fab, over what you are actually consuming in terms of intake plus the recycling that is taking place. So by that virtue, you will arrive at that percentage, whether it is 50%, 40%, 30%, 60%, and so on. Okay? And next time, as I spoke, you would be asked to provide this fake data. In fact, PUB might be asking you even now if you are requesting more water from them. On the left-hand side, Taiwan example is given, and highlighted in yellow is something called as the evaporative losses. So they seems to minus it. So they do gain a little bit more in terms of water recycling rate, but not by a big margin. So still there is a big gap between so-called Singapore fabs versus Taiwan fabs in terms of rate of recycling. So we could do a lot more here. And probably what we are hearing from the industry sources is that the 50% is the mark that most likely going to be kind of a KPI that everybody would strive to achieve, at least in Singapore in the coming years. Okay. A bit about the industry, I think you have heard enough that it's a heavy water consumer. One fab, front end one, easily 1,000 cubic meter per hour or even more, which is very, very big volumes. It is restricting a lot of things, even new investment occasionally are being subjected to a lot of scrutiny because we have water situation now. In terms of so-called growth, it is a very, very fast-growing industry, even in Singapore, and a lot of new fab investments, back-end, front-end. Some you have seen, some are likely to come, and back-end is still continuing. In terms of challenges, basically you have challenges like organics in your wastewater, you have solids, and you have so-called salts or TDS. Of course, there can be little more challenges than that, but these are the three major challenges that you are faced with. And if you go and talk to the fabs in Woodland, they are right now having opportunity to recycle the water more, but the problem is they have a discharge situation, meaning when they discharge this water, wastewater, they have to meet certain criteria of PUB, and which is about 3,000 TDS, 3,000 ppm of TDS, and they are not able to meet it. So there is a circular thing going on, so please keep in mind that adding more chemical while you are doing the wastewater treatment is going to make you hit that ceiling of 3,000 ppm, or even chloride of 400 ppm or sulfate of certain number of ppm. So all this has interlinks with each other, because remember what you are going to discharge is going to go back to PUB and to become new water. This is a bit of a pyramid just to explain some basics about it, where the MPPE technology that today is the focus of discussion is sitting. So basically the bottommost tier of the pyramid was when 25 years ago, we were all just trying to achieve a UPW spec and that's it, and wastewater treatment spec and that's it. We were not bothered about how to recycle. From that phase onwards, the middle tier shows you that we started doing some recycling, some rinses, and now the next tier is to go even further. Even the concentrate streams, can we do more about it? And that's where MPPE and some evaporative technologies come into play. Here, today's topic of discussion, we have circled it. It's about a stream that contains IPA in the wastewater, which many of the fabs are using. Not many, in fact, most of the fabs will have to use IPA in one way or the other. So here we try to show you a kind of a circular economy situation, whereby at the top what you see is a kind of a factory or a fab. Of course, it won't have a chimney normally, a fab, but just for the simpler representation. And then you get a UPW. Here UPW stands for something called as ultra pure water. You add chemicals to it, maybe some gases to it, and put it into your tools. And then what you get out is wastewater. Yeah? That wastewater may contain whatever you have added, plus, of course, a lot of chemical reaction has happened. The problem that you are facing today is that you want to separate the two out, but actually what you are doing is through ROs or reverse osmosis and etc., you're concentrating it. You're concentrating it and sending it to PUB to treat it. So you're passing the buck from your fab to PUB in literal sense. The ideal situation would be for you to separate the two distinctively so that you are not, creating or passing the pollutant to somewhere else. And the answer lies in this kind of technology, which is MPPE or microporous polymer extraction. By the way, this is a picture, or rather a 3D drawing model for what we are going to have in Taiwan. It's being installed right now. So what is the comparison? So you might have heard, some of you who are in utilities or some of who are in operations, you would have heard things like reverse osmosis. So reverse osmosis and ultrafiltration, if you can focus on the yellow highlighted portion, will always have some reject water. So concentration or so-called percentage may vary. It can be shown as 10% and 25% for reverse osmosis, but it could be at least around 75% in terms of overall recovery. So this again repeated to keep the point clear that what you are sending out to sewer is eventually turning into a new water. And some of the fabs in so-called woodland as well as some in Pasir Ris are right now facing some TOC issue because the pollutant are being sent out of the fab. The organics have gone in and coming back to you again. And some of them are causing you trouble in terms of achieving TOC in your UPW water. What MPPE does is basically it removes the chemical, at least the organic part of the chemical, and sends out the water. This is how the so-called MPPE media looks like in the first 2 or 3 pictures. And it is very small, like a sugar granule size, and it has a porosity. So within the pore, there is this wonderful extraction liquid sitting. And this extraction liquid is the key. It is what is actually doing the extraction or absorption in case of IPA from the wastewater stream. And we basically work on the principle of swing extraction or absorption, meaning based on the temperature, it works to either extract or absorb, and then at a higher temperature, release whatever pollutant it has extracted or absorbed. This is a bit of a so-called audio-visual, but I would say that rather than focusing on too many equipment there, basically the principle is there are 2 vessels, and within first one is doing the pollution removal or so-called chemical adsorption or extraction, and the second one is releasing it while doing the steam implantation or steam regeneration. What happens when the steam comes, the pollutants are released, and the pollutants are then condensed into a condenser, and that is retained as your pure chemical or so-called organic chemical that you derived out of the wastewater. So it's very different compared to reverse osmosis. These are the kind of system sizes that you would end up seeing. So in the center, there is some pilot plant for you to try it out. If you are new to this technology, and just on the right hand side, what you see is 2 containers sitting one on top of the other, a 40-foot container that can handle roughly about 50 meter cube per hour capacity. This is an example of a so-called Philips in Germany, where we were removing a pollutant toluene. So the most interesting part for me here is what you see in terms of toluene in terms of inlet is about 500,000 ppb, and what you get out is 50 ppb just in a single step. What you see in the picture on the upper side of it is a stainless steel vessel. Those 2 tiny vessels are doing the job. In terms of comparison, I think typically you would always use, industry always uses UFRO or MBRRO, and here is where the big differentiation comes about. Those are membranes. They will have their own issues in terms of scaling, fouling, etc. And also they will have issues in terms of recovery, which we spoke about. It's a concentrating technology. You haven't removed the pollutant, you have just shifted the pollutant. And in terms of other competition, in terms of distillation still, etc., it is very, very high OPEX because steam consumption for distillation still is distillation column is extremely high, yeah, to the scale of like 10 times of what MPPE would do. This is a long list. I don't expect you to read through, but basically some of the highlighted ones are the ones which are used in either front-end or back-end fabs. So if you have even more of the organic chemical, please do reach out to us. We can do the separation. This is the slide straight from PUB. So we have taken permission of PUB to present and even broadcast even further that there are a lot of grants available, because there are always hesitation and things like that how do I get started, or how do I fund it, etc. So PUB has been so generous. They are even giving you funding for piloting it, doing testing, initial testing, meaning water testing. So basically they are really after you to get it started. So, and then there is of course the big thing is the last bullet point on the right hand side, funding for the capex for innovative technology. So far Singapore, none of the fab have so-called install this MPPE technology. So if you are the first fab to install it, you would be ending up with this 4 million grant, which is extremely lucrative, yeah? So that's one, and even if you are second or third, doesn't mean that the grant stops, by the way. You still get all the 3 grants, but the 4 million will drop to something like 1 million. So more or less on concluding it, go towards MPPE kind of a technology which is able to do the separation rather than, kind of diversion or concentration of pollutant. And by the way, one thing which I did not speak about, that this IPA that we are capturing is resellable. Obviously, you would ask, can I reuse it in my fab? Answer is no, because the purity of your IPA requirements are too high. But yes, it is resellable to a secondary industry like, thinner industry or turpentine makers, etc. The second one is, of course, it helps you with the ESG, rate of recycling. So rate of recycling is going to come soon for you whenever you are going to ask for your extra water from PUB. It's a non-membrane technology. We spoke about it. Membrane has its own issues. Some of the users who are sitting here and we have been discussing has its own issue and so-called problems. It's very compact and modular. By the way, the system that we are installing inside the fab in Taiwan, it's going to sit inside a sub-fab, yeah? So in the basement. So it's very compact. So having said all, it is very low OPEX also. So everything said, it is really a step forward towards circular economy and sustainability with very, very unique separation methodology. So please take a first step, go for the lab test or go for the piloting plant, because there are fundings there waiting for you to be so-called encashed. Okay, with this, I open the floor for questions.
Yes, Mr. Mehbub, but I do have questions for you with votes. Okay, what is the energy usage to run MPPE system as compared to conventional method?
Okay. So conventional method, I think there was a slide though, that there is a conventional method, there are 2 things to be compared, the membrane system. So membrane system, you would have a tremendous amount of energy use, whereas in MPPE, I just give you a KPI. So you are using, let's say in this case of IPA removal or IPA separation, you are using hardly about 5 kgs per cubic meter of water. And this steam is not very high temperature steam, by the way. It's only about 107, 108 degrees. So it's relatively very, very fast in terms, the OPEX is seriously very low, and that's how the KPIs or so-called ROIs are also relatively faster. So that's as far as one technology is concerned. The other one, which we also had a slide about, which is more about so-called column, and column versus this is a factor of 10, simple. Yeah.
Thank you. Speaking about ROI, we have another question. What is the typical ROI for installing MPPE system?
Yeah. So it's a bit hard to generalize it, but with the case in the presentation, where we are doing the IPA and UPW or so-called DI water separation, it was working out to be around 3 years. It will be different for you if 3 to 5 years. If you already have some system like RO membrane, etc., then it would be a little bit longer. But otherwise, the range is about 3 to 5 years.
Right, 3 to 5 years. Okay, next question for you. For such MPPE system, can the filter be regenerated or being disposed each time?
No, absolutely. While the audio visual was showing, because there was too many things happening there, but I tried to simplify it. There's always 2 vessels. So whenever you saw the pictures, etc., there are always 2 vessels. One vessel is working and the other one is regenerating. So there is always a service cycle happening and a regeneration cycle happening. So that's why it goes in a pair. So no, you are not throwing the media, not at all. In fact, this media is pretty robust. It is used, the technology was developed, by the way, for the oil and gas people 30 years back. So it's pretty robust. In oil and gas, the kind of pollutant you are looking at is not so clean as our semicon. So it lasts there about close to 10 years. So our estimate is it should last longer than 10 years in terms of media life.
Thank you very much for clarifying. Next, what is the switching cost to the MPPE system?
Yeah, so it is again a very generic question. It is a bit harder to work out and tell you a kind of number. What we suggest that if you already have a recycling system, but it is not effectively removing the pollutant, especially the organic pollutant, please do talk to us. We will have to analyze it before we can answer you a specific question like that, how much would be the cost, switching cost. But just to give you a rough idea, again, being the case of Taiwan, it was around, let's say a ballpark number for you, 100 meter cube per hour system would cost you everything inclusive, turnkey basis kind of a situation would cost you around $10 million.
Right, thank you very much for sharing the figures. One more question for you. Is this membrane technology targeted for only one solvent, or can we use it for mixed solvent recovery?
Yeah, right now this is what we are doing, a lot of testing and kind of development. I won't call it a research. We have different media. What we showed you is just one media for one specific chemical. So we carry a kind of an array of medias, and it can be deployed in a nice different configuration so that we could achieve even a multi-pollutant extraction. So this is something, once this is achieved, it will be really a game changer. And even without it, to us, it is a game changer technology because it's not a concentrating technology. It's simply separation technology, removing it and giving you one side chemical, one side all the water.
Thank you. Thank you very much for answering all the questions that we have. I think that's good. Shall we all give a big hands once again to Mr. Mehbub?
Thank you very much.